Hello, I'm Tony Ko, the host of TalkIT Global. Is using the latest high-performance GPUs enough to maximize AI infrastructure performance? Before that, fast and efficient networking between compute and storage must be in place to fully unlock the GPU's capabilities. In this episode, we'll explore the hidden key factors for optimizing AI infrastructure performance with Se-jin Oh, CEO of AI specialized company 10.
The second important component is storage. It's a part that many people tend to overlook. Why? Because everyone's in a rush to get GPUs. So when budget becomes available, they often buy GPUs first. But from the perspective of interconnecting systems, let's say you have 100 servers and each server has 8 GPUs. That's 800 GPUs in total. You can't realistically copy the training data 100 times across all those nodes, right?
Exactly.
It's not just that the data is large, we also have to manage it ourselves. So when we say we can't copy data to each node, it means we must place the storage externally. From there, all 800 GPUs need to access the data in real time. In the old big data era, the role of storage was mainly to store data somewhere. Just dump it. You'd store it first, then pull bits of it later when running big data analysis. But now, if all GPUs are constantly and simultaneously pulling data, the networking gear connected to the storage becomes incredibly important. Yet this is something many people still overlook. Even if you bring in the latest Blackwell GPU, it still can't train without access to data, right? That's why data transfer becomes a bottleneck. If you haven't paid attention to this part, your GPUs won't be able to train properly, even after spending all that money. And by the time you realize it, your annual budget is gone, and it's too late to fix it. If the rise of artificial intelligence marked a major shift in hardware architecture, then previously most applications using VMs and CPUs ran entirely within a single node. Unless you were working with a supercomputer or specialized source applications, everything happened on one server. But with the shift to AI, there was a fundamental change in hardware. Systems now needed to be interconnected. That's when networking became critical. At the beginning of my talks, I always emphasize that there are 3 types of networks that have become essential, and I explain them by category. The first one is compute fabric. This is often referred to as InfiniBand. Recently, ROC has emerged, an Ethernet-based protocol that implements RDMA. You don't need to know the deep technical details, just the concept. Essentially, GPUs across different servers need to exchange data, but if they do this through traditional RAM pathways, it becomes a bottleneck. In short, it's too slow. So compute fabric can be seen as a kind of high-speed physical highway built specifically for GPU to GPU communication.
So it's like creating a dedicated line just for GPUs.
Yes, this is actually one of the most critical parts of the infrastructure.
The core of AI services now lies not in the model itself, but in optimizing the underlying infrastructure. Since most AI software runs in containerized environments, Kubernetes infrastructure strategies for managing multi-GPU clusters reliably and boosting performance are becoming more critical than ever.
And finally, the last key element is Kubernetes. As I mentioned earlier, containers are running on all these GPU servers and someone needs to orchestrate them. Through Kubernetes, I'm the foundation for managing these containers and we can manage them as a single workload and process them as a unified task. This shift toward network-centric operations is one of the major paradigm changes we've seen recently. Properly setting up this environment is critical, and being able to run it in a containerized way is just as important. Our company provides services that support both of these perspectives.
So as we move toward operations, the importance of containers becomes even more pronounced.
Exactly. In the past, resources were managed at the VM level, but now things have completely shifted toward containers. Especially with LLMs, they're often distributed as Docker images right from the start, so you have no choice but to use them as is. That's why, from an operational standpoint, Kubernetes-based container orchestration has become essential. These are the 3 major shifts we're seeing in the current infrastructure landscape.
Lastly, your likes and subscriptions greatly empower us to continue creating content. Thank you for your support.